I've never seen a number like a ghost. I never had to multiply by infinity, and I'm not sure how to compare 1 0 to another 0, but every song's like differential and infinitesimal, Newton's method, theorems, fundamental calculus. It's not as difficult as it seems, with epsilon and delta limits, L'Hopital and Leibniz, Hooke and Riemann, infinites with sizes, if you please. Just throw it back to Archimedes, and you know the difference. Infinite and infinity, infinitesimals are small, as if you had nothing at all, but they're bigger than 0. Vacuum finite quantity. A differential odyssey. Done. Yes. 40 more integrals? Are you kidding me? I just want to go to sleep. Stupid calculus, stupid Isaac Newton, stupid abstract math. Seriously. When am I ever going to use this? Why didn't I take statistics, or probability, or finance, or German, or something useful in the real world? Darn you, Gottfried Leibniz. Darn you, Riemann. Darn you, Robert Hooke. L'Hopital, you're cool. But most of all, darn you, Isaac Newton.
Who are you? I am Isaac
Franklin.
Newton.
What are you doing here?
I must be dreaming. No, I'm dreaming. I'm dreaming. I'm dreaming. Look at your clothes. Look at your hair. What's wrong with my hair? Stop copying me. No, you stop copying me. Stop it. Stop it. Stop it. Okay. On the count of 3, say the first thing to pop in your head. 1, 2, 3. De motu corpus in gyro.
Oh, that's better.
I'll say, this is a strange dream, eh, little Isaac?
Hey, what makes you think I'm in your dream?
Because I just had my reoccurring dream. And like all reoccurring dreams, I'm fairly certain one was about to reoccur.
What was your dream?
Falling. I was standing on the lip of a well when I received a push. Naturally, I suspected Robert Hooke. As I fell for 100 feet, I felt very odd. Because in my dream, as I fell, my speed never changed. You don't look very shocked. Let me be clearer. Instead of speeding up as we used to do in falling, I started faster than expected and just stayed that speed. Then I woke up, went to the kitchen, and ate a pastry, fruit and cake. And while I waited for my dream to reoccur, I conducted rigorous physical trials on little Isaac here.
Yeah, about little Isaac.
When I drop him from a height of 100 feet, he always takes 2.5 seconds to land.
Okay,
and on that journey has an average speed of 40 feet per second. But he does not start at 40 feet per second, nor does he land at 40 feet per second. My dream is not right.
Well, okay.
He must speed up. Because when I start him, he's not going very fast at all.
Yes,
It's very frightening. It means at every point along his journey, he's traveling at a different speed. But how can I measure speed at just one point? The only way I can measure speed is to divide distance by time feet per second, but in one instant, there is no distance, there is no time, there is no value at this point. Oh, thank you. I needed that.
You are nothing at all like I expected.
Ooh, who were you expecting?
I don't know. I guess I thought the inventor of calculus would be someone a little more grounded.
I was just talking about falling. How more grounded can one get? Ground.
I wonder if I'm going to dream about any of the other mathematicians from my textbooks, like Guillaume Francois Antoine Marquis de L'Hôpital, or Gottfried Leibniz, or Archimedes, or Robert Hooke.
Who?
Robert Hooke?
Who?
Robert Hooke.
Who?
Robert Hooke?
Never heard of him.
You just mentioned him a couple minutes ago. Well, you totally know who I'm talking about.
Nope.
English scientist. Curly red, wig. Squinty eyes. Small mouth. Robert Hooke.
Robert Hooke!
Hello, Isaac. It's me, Bob.
I've been meaning to remind you, Mr. Hooke, about the marvelous properties of prisms and how they distinctly break white light into different particles.
Oh, I think you'll find, Sir Newton, that the light is not being broken, it is merely being changed.
I think you'll find, Mr. Hooke, that had you done the experiment and had you done it correctly, you would have reached the same conclusions that I had.
Oh, I did the experiment correctly, and it led me to conclude that your ideas are stupid.
Light breaks up.
Light doesn't break.
Light is a particle.
Light is a wave.
Particle.
Wave.
Particle.
Wave.
Particle.
Heavenly spheres.
Aha! Science.
Oh, how about a little research on elasticity?
Friction.
How's this for standing on the shoulders of giants?
God, you sprinkling psychopath.
Fancy a little fluid dynamics?
No. Microscopic maniac.
Why are you-
I'm not touching you.
Stop it.
I'm not touching you.
Stop it.
The finger draws closer than any measure could exist, but I'm still not touching you.
Stop it.
The distance decreases from 1/millionth of a hair's width to 1/billionth of a hair's width, but never will the finger touch your vile flesh.
Stop it. There's no point to this tomfoolery. Your treachery knows no limits.
It's gonna have his way tonight. His fingers on their way from left and right. You say there is no point there, so what? A limit can exist there even if there is not a point. And if I may be on point, I'm going to demonstrate and point in your face. As my finger draws me in a rude invasion of your personal space. It's getting closer, but never touching you because you are too gross. That's right!
Old Hook feels like he's gonna croak tonight. I'm gonna crack you like your broken light. As epsilon and delta grow small, their arbitrary values near nothing at all. But fight! There is no option of flight. You aren't touching me, so I won't be swayed. The distance drops to a hair, but just remember that you've never been paid.
Is there a limit?
Is there a limit?
A limit how low you will sink in the fire. Bite! I'm tracing back along the flow inside. Emergent fluxionisos to slide.
I'm meeting at the middle. Value, an answer to the riddle, is coming up through
The right,
from the left and from the right.
and if they need a limit, is there?
It's
Tight,
alright.
from left concurs with right. If they need, then our limit is there. The space between them is so tiny,
One might say microscopic,
but something smaller yet. And when
they meet,
a a value will exist. Its might be right. Instead of finding little Isaac's speed at a particular point in time,
We find little Isaac's position at a particular point in time.
then we find his position an arbitrary amount of time later.
Then we use the notion of the limit to slide the amount of time that passed to become infinitesimally small.
I shall call this a fluxion.
Yeah, we'll work on that.
Then we find the distance between his first position here and his second position here.
This distance is also infinitesimally small, but now, when we divide the infinitesimally small distance,
By the infinitesimally small time, we get a normal, everyday, finite number like 37 feet per second.
this is little Isaac's instantaneous rate of change.
His speed at just one point.
His slope,
His derivative. I can find little Isaac's instantaneous rate of change at any point along his journey. I shall call this y dot.
Y dot.
Why not?
Hey, where are you going?
To play with my metals.
Aren't you going to tell anybody about your discovery?
Why?
Because it's important?
Why?
It's a major principle of physics?
So,
So what's more important than that?
the Philosopher's Stone.
What?
It can turn anything into gold.
Are you being serious right now?
Yes. Toodles.
Hey, if you don't publish, somebody else is going to publish first. They're going to come up with better names for your functions. You're going to have to share the credit. Okay, we'll do this your way. Hello, Isaac. It's me, Gottfried Leibniz.
Not German enough.
Hello, Newton, it is I, Gottfried Leibniz.
Leibniz?
Guess what I just published?
You didn't.
I did. Now I know we have this little disagreement as far as who came up with exactly what and who came up with it exactly when, but at least there's one thing we both know for certain, and that is who published first, right? But we are not so different, you and I. It's just that one of us is a procrastinator, and the other is a German. But I looked at your work, and I think we agree. But the words that you use are confusing to me. You say the word fluxion, and it is essential that I mean the same when I say differential. Now you say y dot when you mean the change of distance to time, which I think is strange. I think it is clearer if you were to say dy dx, differentials at play. Now consider a curve, f of x as it's called, and 2 points are a distance apart. The distance is h and it drops till there ain't any way that will tell them apart. The height of point x is simple to find, f of x as its friends like to call it. The height at the other point, x plus h, f of x plus h, even though it sounds strange. Now subtract them, divide, and take limit. F of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative to otherwise state instantaneous rate.
F of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative to find the slope at one point. Infinitesimals dy over dx. Why he wrote it I can't say.
I just liked it better that way. So f of x plus h minus f of x all over h as h drops to 0 is the formula to find the derivative.
This I will have to learn to call Leibniz found the limit of the slow.
Yeah. Daddy's English monkey.
Oh, flexion!
Differential.
Infinitesimals divide over dx.
Why I wrote it out that way.
Leibniz liked it better that way,
So f of x plus h minus f of x all over h is h drops to 0 is the formula to find the derivative.
To call Leibniz found the limit of the slope. Game?
Hey!
Are you done? Hey! That's Leibniz, everyone. Clap.
So, are you going to publish now?
I guess so.
I guess so.
Stop copying me.
Stop copying me.
I mean it.
I mean it. Stop.
Oh, Germans. I'm German and I like to publish things. I'm so cool. I say the word schnapp.
I just made that up.
I'll show them how a real scientist publishes. Yes. The derivatives of polynomial functions by Sir Isaac Newton. The derivative of x to the power of 5 is 5x to the power of 4. X to the power of 4 becomes, stop it. 4x to the power of 3. X to the power of 3. F of x plus h minus boring. There's got to be a better way. Every time it's f of x plus h minus waste of time. To heck with publishing.
Can I take a look? Okay. Every x to the power of 4 becomes an x to the power of 3. Every x to the power of 3 becomes an x to the power of 2. Every x to the power of 2 becomes an x to the power of 1. Yeah, but then there are these numbers in front that keep changing. I think every different power has to have its own unique rule.
Well, I'm stumped.
What, so you're just gonna give up? This is a group project now, buddy.
Everybody knows a group project is an excuse to slack off and eat fruit and cake while someone who cares does all the work.
Isaac! Come on, man! I'll have you know I have been up all night studying your stupid rules. Thanks a lot. What a nightmare.
Have you ever had that nightmare where you're standing on stage in front of an entire school?
Oh, I have that one all the time. It's the worst because you're stuck and they're stuck and nobody can get lunch and
Right.
Oh, no, Isaac, no, come on, no, we can use this. No, this is good. We can use this to solve our problem because in my dream, there's an energy that takes over the crowd and they can't stop cheering.
Well, cheer, come on!
And a dramatic wind swirls through the auditorium for theatrical effect while the audience can't stop losing their minds!
This dream of yours, wow, it's as exciting as my experiments with Mercury.
I'm gonna harness the power of my dreams and solve this problem of powers with a power ballad.
Uh-oh.
You're gonna reveal. to the half power. X to the -1, A1 over X tower. When you need the change, X to the B. How to change it from X to the B. I believe in the power rule. Any X to the B -1, any other X to the B. Polynomials of 90 degree. I believe in the power rule. Good job. I believe in the power rule. Any X to the B -1, any other X to the B. Polynomials of 90 degree. I believe in the power rule. I'm starting to like you.
And I you. We are best friends.
Well, I really
We
said
are
that.
inseparable.
I did not say
We
that.
shall have a jeweler make us a little metal heart with the letters BFF engraved on it. For best friends for eternity. Then we shall break the heart in half and each carry a piece to remind each other of our undying friendship.
I hate to break it to you, but you are not my best friend.
Oh, I will be. It is mathematically proven.
Really?
Yes. Did you like me when we first met?
No. Well, no offense.
Oh, none taken. Did you like me better after I stopped copying you?
Yeah, I guess so.
And what about after our first song?
Okay, that was pretty fun.
And when I had to poke my eyes out? And now you're liking me.
Well, yeah, but that doesn't mean we're best friends.
But if we continue this mathematical trend, we shall soon be the greatest friends the world has ever known.
But my rate of liking you is decreasing.
I don't follow.
Can I borrow little Isaac for a second?
Oh,